So let's go through a couple of samples together, and then we'll move on from there. So just by looking at a graph, like on your day 8 homework packet, we can use everything we know about transformations to determine the equation of that function. So for the first example, if we look at this equation and go back to that very first day when we were just getting to know our parent graphs, and I asked you in your yellow packet to just name the parent function, just tell me the shape of the parent function. This is when we're going to use that. So by looking at the shape of this graph, it seems quadratic to me, or x squared, like a parabola. So we're going to name our parent function as f of x equals x squared, and I'm going to graph that parent function because as I graph parents and then continue to move them around, I can end up with my final equation a little bit easier. So my parent parabola, we know it well by now, 0, 0, 1, 1, 2, 1, 2, 3, 4, and so on. Okay, so there's my parent graph. Then we list the transformations that we see. So the most obvious transformation for me is that the parabola is upside down. So that transformation is a line reflection over the x-axis. And then I remind myself that what in the equation, that's a negative out in front. So I would change my equation to f of x equals negative x squared. And you're going to want to graph that as well. So these don't have to be perfect or lovely, but just a reminder about the changes that happen right along the way. Now, so now I have the direction of my parabola correct. Now I need to shift it or translate it. I'm going to translate it to the left and up. So how far to the left did this translate? Well, I give you the vertex of negative 4, 6, which means it translated left 4 units. I'll change colors. So the next transformation I see is a translation, oops, sorry about that, translation left 4 units. Well, let's graph that. 1, 2, 3, 4. And it's that last graph, the one that's still upside down, that's been translated 4 units. Now, in our equation, left and right transformations have been within parentheses. So we could start out by saying f of x equals negative, and I'm going left 4 units. Standard form is x minus. Left 4 is negative 4. That is where the vertex or turning point or new anchor point of my final child graph matches the equation. So x minus, general form, negative 4 all squared for my parent. Now, of course, we'll clean that up in the end, but for now, you can leave it alone. It helps us see what's happening. All right, so I've got my parabola going in the right direction. I have it moved to the left 4. My final move has to be to take it up those 6 units, and we'll land on top of that final child graph. And what we've learned as we've been going through the last week or so is that a translation vertically, up or down, in this case up 6 units, is a plus or minus at the very end. It's the k value at the end of my equation. So now I would have f of x equals negative x minus negative 4 all squared plus 6 for my translation up 6 units. So there's the work I want to show. I want to think about the parent function and each individual transformation, and we build the equation from each transformation. And then the final equation, all cleaned up, will be f of x equals negative x minus a negative 4 is x plus 4 all squared, there's the parent part, plus 6 for that vertical transformation or translation up 6. And there's your answer. Not so bad if you know your parents and you know your transformation rules. Let's practice a couple of more. Now I gave you much less space here, really just in an effort to save some paper, but we can jot the work down off to the side and we can start using symbols if we want to. Okay, so following our steps from up above, we want to first say, I wonder what the shape of this graph is. What parent might this be coming from? And we're going to list it. This parent is y equals x cubed. It says the x cubed shape. So I go to 0, 0, my anchor point, and I sketch in the parent x cubed to get me started. And then I say to myself, well, what transformations have happened? Well, it's been shifted or translated to the right 4 units and up 3 units. Take them a piece at a time. So a translation right 4 units would move this parent graph over to here. And with the equation, it'll make it left and right inside of parentheses. I moved to positive 4, so I will have y equals, or f of x equals, x minus a positive 4 cubed. It's a cubic parent. Then I want to take that parent, or that new child, and move it up 3 units. So that is a translation up 3 units to get from my red graph up to this final graph that I was given. And so in my equation, I add the plus 3 at the end. Y equals x minus a positive 4 all cubed plus 3. We want to always clean that up because we're big kids. So I'm going to write that as y equals x minus 4 cubed plus 3. And that is the equation of the graph. No inspires necessary. You know your parent graphs, you know your transformation rules, and it actually ends up being quite simple. Okay, the last example, sample 3, is very similar. Try to get my paperwork in here. Okay, and I want to show you, for those of you who have already noticed that some of these translations can be done in one step, that's fine. You just want to be careful, but it's not wrong to be able to save yourself some time and clean up some of your work. So first thing, of course, is to figure out the parent. This parent is our square root function. Y equals the square root of x. When I sketch that in, it looks something like that. Now, what's happened to this parent to land in its final spot? Well, it's moved left 6 units and down 3 units. Left 6, down 3. And lots of us are seeing that these numbers are always showing up in our equation in vertex form, and that's one of the major points I want to make. That's one of the major connections I want to make, is that as soon as you start to see that anchor point and how it's moved from its original 0, 0 for our first 4 to its resting spot, those numbers in the final anchor point are within your equation. So some of us will get to the point where we can do this in one step, and I'm going to show you that with sample 3. If you aren't ready for that, that's okay. Break it into individual parts. This is just a little bit of a quicker way of doing things. So the left 6 stays inside my grouping symbols. So I'll have y equals the square root of x minus negative 6. Left 6, negative 6. Down 3 units outside of my grouping symbol, minus 3. And then we clean that up. Y equals the square root of x plus 6 minus 3. And that's it. So, if you find this easy, fantastic. If you don't, think about why. Try to come up with the reasons why. Do you not know your parent graphs well yet? Are you not comfortable with the different transformations yet? Think about what you're stuck on and bring those questions to class so that we can make those connections together, because you're probably not alone. And talk to your classmates, and the classmates that are really getting this are the people that you want to talk to, because maybe they'll explain it in a different way than I do that will make it better for you. So that's the end of day 8. I look forward to doing more of this in class tomorrow. Have a good night.